Welcome to this explainer. We're jumping straight into what is literally the defining professional transition of our era for developers, moving from prompt engineering to systems engineering. If you've been relying on massive, complicated prompts and just kind of crossing your fingers hoping for a reliable output, well, what we're unpacking today is going to completely reshape how you build and scale your applications. So let's start with a hard truth. The ceiling we're hitting in 2024, it is not a model capability ceiling. It's a design pattern ceiling. Stuffing absolutely everything into a single prompt creates unpredictable failures. And that's not because models like GPT-4 or Claude lack capability. It's simply due to poor architectural design. Remember, large language models are stochastic processors, meaning they sample from probabilities. When your entire application logic lives inside one massive prompt, all that uncertainty propagates directly into your business outcomes. To fix this, we need a totally new blueprint. Today we're covering the death of the linear prompt, the microagent blueprint, why state machines beat raw model power, tracing nonlinear paths, and measuring agentic success. We're going to dismantle your old workflows and logically rebuild them into a robust system piece by piece.
Section 1. The death of the linear prompt. We are upgrading your architectural philosophy. Right now, we're right in the middle of a massive paradigm shift. We have got to move away from treating the model as an oracle. You know, that outdated idea that the model has complete knowledge and should give you a perfect, magical answer in one go. Because when an oracle fails, it's a catastrophic failure. Instead, we're shifting to treating the LLM as a bounded processor within a state machine. It takes a defined input, processes it, and produces a defined output. If it fails, you can easily inspect exactly what transformation went wrong.
This brings us to a trap so many fall into: vibes-based development. You know the drill. You eyeball a few outputs, declare the prototype works, and completely ignore edge cases. But relying on these good vibes forces you to restart from the very beginning when a multi-step process eventually hits an error. And when it inevitably breaks in production, you end up burning tokens, burning latency, and worst of all, burning user trust. We absolutely need predictable patterns, not good vibes.
All right, moving to Section 2, the microagent blueprint. Let's talk specialization and boundaries.
To prevent context pollution, you need to break that monolithic model down. Instead of one model doing everything poorly, you use specialized single responsibility agents. You have a research agent solely to gather info, a planning agent to decompose goals, an execution agent to carry out actions, and a validation agent to check the outputs. By giving each agent just one job, you prevent role confusion and optimize their context windows. Plus, it lets you test nodes independently and swap them out whenever needed.
And breaking things down prevents a massive pitfall we really need to avoid: context drift. It's this incredibly insidious failure mode where an agent accumulates so much history that it gets confused. Its outputs start reflecting earlier context rather than current instructions. This is exactly why your orchestration layer must enforce strict input boundaries. You have to guarantee each agent receives exactly what it needs for the task at hand, and absolutely nothing more.
So how do these isolated agents talk to each other? Well, you need a formal handoff protocol. Think of it like a strict internal API for your agents. Without explicit metadata like task identifiers, completion status, and error codes, your chain is going to break the second and output format mismatches. That causes unpredictable workflow halts. Your protocol has to specify not just the happy path, but literally every anticipated failure mode.
Which leads us to Section 3, state machines over model power. We are talking deterministic control.
Okay, this is arguably the most counterintuitive yet crucial rule of agentic design. A mediocre model with excellent state management will heavily outperform a frontier model with poor state management in production. A powerful model without state tracking will just repeat mistakes and hallucinate solutions to problems it actually already solved. But tracking the workflow state persistently, that lets you recover from exact failure points without starting over. The model doesn't have to guess what happened, your state machine tells it perfectly.
And to maintain that kind of tight control, you need hard-coded guardrails. Honestly, giving an AI complete autonomy is a fast track to disaster. You have to enforce explicit constraints at the task level, loop limits for retries and timeouts, and system-level rules for cost and governance. You do this through deterministic code, not prompts. Models are amazing at semantic reasoning, sure, but your code must handle the structural logic.
The best way to build those guardrails is by forcing agents to output valid JSON objects based on structured data schemas. Free-form text responses are incredibly fragile and require super error-prone parsing. But with structured schemas, you create paved roads. Your orchestration layer can instantly read a field and make a routing decision in microseconds with zero ambiguity.
Next up, Section 4, Tracing Nonlinear Paths. Let's dive into observability and reflection.
When you move beyond simple linear lines, you need a powerful self-correction mechanism built in. It usually looks like this: a generation pass, followed by a specialized critique pass to evaluate facts or formatting, and finally a refinement pass. Implementing this kind of multi-pass reflection loop dramatically reduces downstream errors. You catch the mistakes right at the source, way before human review is ever needed.
But what happens when things do inevitably go wrong? You need real observability. You have to replace traditional sequence logs with structured trace events, logging the task ID, the agent ID, the exact payloads, routing decisions, and token counts. Because these execution paths are nonlinear, you need tracing that reconstructs the full execution graph. That turns an hour-long debugging nightmare into a 10-minute structural fix.
And here is an amazing side effect of this architecture. You can actually achieve a massive 60 to 80% reduction in inference costs. How? Because your orchestrator can dynamically route simple Tier 1 tasks to small, fast, cheap models instead of pinging an expensive frontier model every single time. You match the task complexity to the model capability.
Finally, Section 5, Measuring Agentic Success. We are redefining performance. Here's the deal. Output fluency, just having the text sound eloquent, is practically worthless as a production metric. You've got to abandon the vibes. You need a new scorecard based on hard engineering metrics: task completion rate, internal error recovery rate, cost per task, and human intervention rate. A system that actually finishes the job 99% of the time and handles its own errors is vastly superior to a fragile system that constantly needs a human to step in, no matter how pretty its text generation is.
Take a step back and look at the trajectory we're on. We started 2023 playing with linear prompts. Today, we're building these robust multi-agent systems. And all of this, it's direct preparation for the near future of interoperable agent tech operating systems. Building with abstraction and modularity today is absolutely your best tool for future-proofing your apps.
So, I want to leave you with one final thought to chew on. Ask yourself right now, are you trying to build magic with better prompts, or are you actually engineering reliability with better architecture? Real production readiness does not come from finding a magical combination of words. It comes from strict architectural discipline. I challenge you to look at your own workflows today and fully embrace this transition to systems engineering. Thanks so much for joining me on this explainer, and happy building.